All right. So I was a little bit busy with this human here who came along at the university. They are doing their first years. And surprisingly, the chemistry that I was doing is related to what you guys are doing here in grade 10, even in grade 11. So exactly what I was talking about when I was talking to you guys. But anyway, either way, I just want to check where we left. We did the mixtures. We spoke about two types of mixtures. We even went through each and every type of a mixture. We explained it. We went through the heterogeneous mixture. We also explained that. We looked at some of the examples and the techniques that we can make use of to separate these types of mixtures. We even looked at these different types of mixtures and we spoke about what techniques can we make use of to separate them. And I also tried to explain how does the chromatography works, stuff and that what, and then yeah, and then now, did we talk about? No, we did not. So today we're gonna start here where we're gonna talk about the pure substances. Okay, so we're gonna talk about the pure substances. Remember, this is matter and materials. Um, we are studying matter and materials. So we looked at definitions on how to define this concept, which is matter and material. So now here we're going to talk about the pure substances, right? So when we talk about the pure substances, we say they consist of only one type of substance and can't be separated by physical means. So what can you think about as a pure substance? You break it down, you still get the same thing. You break it down, you still get the same thing. So when we talk about the pure substances and we talk about the mixture, we're talking about mixtures, we are talking about two different things because we know that when we have a mixture, we can break it down to get different compositions. But when we talk about the pure substance, it's something that we cannot break down and get two different things. So when you break it down or you can't separate it, you will still get it as it is. Now, the examples of pure substances are elements, and there are certain compounds that are pure substances as well. Yes, for example, when you think of water, which is H2O, is that a pure substance or is that okay? Elements that are pure substances, it's gold, copper, oxygen, and iron. Can you separate gold? No. Can you separate copper? No. Can you separate oxygen? No. Can you separate iron? No. You cannot separate these. So these are considered to be the pure substances. And another type of pure substances is water. Can you separate hydrogen and oxygen in water molecule by physical means? You cannot do that. You cannot separate water. What I mean is, you cannot separate oxygen, you cannot separate hydrogen from water molecule. So water, it is considered to be one of examples of pure substances. And then let's talk about table salt. Table salt by physical means. Can you separate that? No, you cannot. But water and table salt, you can separate them. That's a mixture. And we have learned that water combined with salt, it falls under what type of mixtures? We have discussed that we have two types of mixtures, right? So, but table salt itself alone, you cannot separate it by physical means. So it's a pure substance. Copper sulfate and sugar, those are pure substances. So there are elements that are pure substances and there are compounds that are pure substances. Now, when you talk about the elements and compounds, elements can't be broken down into smaller substances because they consist of atoms. That's what I have already explained or discussed. The Described to you that element you can break it down like gold. You break it down by physical means or whatever. You boil it, you do it, whatever. You will always find it as gold. It always exists as gold, right? That's why we say gold. That's why we say element. It consists of atoms, and compounds are made of two or more elements. So meaning you know that, right? So Compounds and can be broken down. But for you to break down the compounds, you need to use the chemical means, not the physical means, for you to break down the compounds. For example, if you want to break sodium chloride, which is table salt, if you want to break it down into their elements, you have to perform chemical means, chemical reaction for you to do so, right? But physical means you won't succeed. So compounds are made of two or more elements and can be broken down only by chemical means. Okay, meaning you can break them into their original elements. So compounds, we say they usually consist of what? Let's see. We say compounds usually consist of molecules. Now, here's the thing. You need to understand these terminologies as much as possible. There are elements, there are pure substances, there are compounds, there are molecules. But then at this point in time, when you talk about the molecules, what are we actually talking about? We're actually talking about the compounds. So compounds usually consist of molecules or formula units. We say the elements making up the compounds always occur in a fixed ratio. So meaning compounds and molecules are thus then can be regarded to be the same thing, right? Okay. And then again, we say elements are classified according to their chemical properties and their structures. What do we mean when I say that? For an example, look at gold, look at copper. What are the physical properties of gold and copper? Okay, let's say, let's have a look at gold and silver. Let's make it obvious. Gold and silver. Gold and silver are two different elements, but they fall under different classification. Why? Because gold, it's silver. That's the first uh, property that okay, we can even talk about the chemical property and their structures, right? So the chemical property is how they react. Gold and silver, they do not react the same, so that already it distinguishes their chemical properties and the structure on how they look like, not the same. How the atoms of gold are together and how the atoms of silver are together, it's not the same as it's not the same for both of two elements. So elements are classified according to that, right? So we say elements consist of what? Yes, you can think about it. If you are right, you can say elements consist of metals from the periodic table. We know that we have periodic table of elements. So metals are about 80 of them. Then we have the metalloids, or we can say the semi-metals. There are about 7 of them from the periodic table. And then we have the non-metals, which are about 20 of them from the periodic table. Okay, so elements are composed or consist of these three guys over here. And then let's talk about the general properties of elements, right? These are general and we know them. Um, I don't know why I did not include periodic table here, but I hope you might have it close to you, but make sure that you always have it with you. So now, metals on left of table of our periodic table, we say the metals. What are the properties of metals? It's a general property, right? You don't have to think out of the box, or you don't have to think hard. We know that the metal are usually hard. That's the first property of a metal. That's very hard. And again, another property, some are shiny and good conductors of electricity, and again, good conductors of heat. These are just the general properties of metals, and this is what we know about the metals. They are hard, they are usually hard, they are shiny, they are good conductors of electricity, they are also good conductors of heat. Okay, those are metals. And then the non-metals on the right of periodic table, we say they are usually softer compared to metals, obvious, and they are dull in color. They are not shiny, they are dull in color, and they don't conduct electricity, or they do not conduct heat. So mind you, can ask you in exam or in a test, give the general properties of metals from the yeah, I can even say of metals. So usually hard, shiny, and good conduct. These are just simple general properties of metals, and also the general properties of non-metals, which this is based on the periodic table. The elements are the periodic table of elements. Now, again, we have the metalloids or the semi-metals. We say they have properties of both metals and non-metals, and situated in a diagonal down the table next to the non-metals. Like I said, I'm surprised why I did not put the periodic table over here. And then again, there are certain non-metals that can conduct electricity, and they are called the semiconductors. Like for example, a silicon. A silicon, when you look at it from the periodic table, go through your periodic table, and then a silicon, it is a non-metal. Sorry, it's silicon. Yeah, I think so. I think, wait. Yeah, I think silicon, something like that. Yeah, I think it's silicon, it's semi-metal. If I'm not mistaken, it's semi-metal. And then it can conduct electricity under certain conditions. Here's the thing, we say metals conduct electricity, right? And yes, it's true, metal does conduct electricity, but again, that also depends on situations or conditions. So if metal it is subjected to different temperatures, at some point it might not conduct the electricity. Same applies to semi-metals or the metalloids. We say the metalloids can conduct electricity under certain conditions. What are those certain conditions? We are simply referring to the temperature. So the metalloids can conduct electricity under, see this part here, under certain conditions. That condition, it simply talks about the temperature. Meaning, normally metalloids, they can conduct electricity under high temperature and so forth. But I think that must be here. So here we have classification of elements. We're gonna find out the symbols and the names of 3 metalloids. Let's see, what are the metalloids? What are the non-metals and what are the 15 metals? So this is your homework, okay? I want you to send the answers today in the group. I want you to write the symbols and names of 3 metalloids. Are we hello? Are we still on the same page?
So,
Come again.
uh,
You are breaking. Please try to talk again.
yes, sir, we are.
Okay, this
Can
is
you
the
hear me now?
yeah. This is the homework.
Okay.
One did by the end of today. You're gonna write 3 metalloids, 7 non-metals, and 15 metals. You can write down their symbols and names. Ne?
Okay.
All right.
Yes, sir.
All right.
Thank-
So let's talk about the electrical conductivity of elements. Let's talk about electrical conductivity of elements. Remember, we said the metals are good conductors of electricity as well as heat. And we said some of the metalloids can conduct electricity under certain conditions. And those metalloids that can conduct electricity, we call them the semiconductors. So some metals conduct well, like copper and Ag. Ag is silver. So copper and silver can conduct electricity very well. So if you have a look at these people who steal cables, they steal cables because they know that the electrical cables, they have copper in it. So copper, it is a very valuable mineral, or it's a very valuable substance when you sell it. So that is why the electrical conductors that are all over across the country or wherever, they are made up of copper because copper, it is a very good conductor of electricity. And then we also have gold, but definitely we know that I mean, sorry, silver. We know that silver is worth a lot. This is a valuable mineral, material as well, substance, element as well. So imagine if ESCOM was using, but again, the electric wires that are made up of silver. Do you understand, Mara? What money are we talking about over here? I'm sure everyone could be stealing those cables. So copper and gold, they are both valuable. They're worth a lot of money. So copper is a little bit better in terms of price, in terms of silver. So silver is one of the best good conductors of electricity, but the problem is it is too expensive compared to copper. And then some are metals, but they do not do so well in conducting electricity, like nickel, zinc, and chromium. So these elements over here, they are not doing so well in terms of conduction of electricity. You might get confused, like it's a metal, it's supposed to be a good conductor of electricity. No, they do not. Why? Based on the structure, based on the physical properties or chemical properties of these elements. Sometimes they do not allow them to be a good conductors of electricity. So most of the times when you have a look at the copper and the gold, sorry, silver, we say they have free moving delocalized electrons. You will see that when we do again the chemistry part, when we talk about the free moving delocalized electrons, we are talking about the electrons that lingers around the material. So those free moving delocalized electrons, they are the ones that vibrates, that can move along the conductor while there is a potential difference. Do you understand? Just like how I explained it when we were doing the electrical circuits. So that's why these are based on the properties, they are not good conductors of electricity. So here's the thing. Sometimes this is you, ne? You are a good student, right? You are a good student, but there are certain conditions that can affect you not to perform well. What are those conditions? Maybe if mommy says, you know what, I lost a job and there is nothing that now we're going to depend on, right? Will that um give you an opportunity to always be strong and say, you know what, I'm still gonna be a good student? Yes, you are deep down, you are a good student, but there are certain things that can affect you so that you don't perform the way you normally perform, right, at school. So same applies to these conductors like copper, gold. These are good conductors of electricity, but there are certain conditions that can affect these conductors of electricity not to function properly. So, what are those things? The conductivity of metals decreases with an increase in temperature. So, if you take a copper and you heat it and then you put it in a circuit, it won't perform very well. It won't perform, even though we know that copper, it is a good conductor of electricity. But the moment you subject a copper to high temperatures, then a copper will poorly function under those conditions whereby it is now subjected to a very high temperature. Okay, so conductivity of metals decreases with an increase in temperature. So make sure that your copper, it always experiences the room temperature or lower temperatures so that it can conduct electricity properly. Now let's talk about the conductivity of metalloids. I'm saying to you, metalloids, some of metalloids can conduct electricity. But the problem again is, like I said, this depends on um, phenomenon or circumstances. So when you have a conductivity, um, the metalloids, for them to perform better, It's opposite of what is happening about these other metals. So metalloids usually increase, the conductivity of metalloids usually increase with an increase in temperature. So if you take a metalloid, that is a good conductor of electricity, a semiconductor. If you take that metalloid and you subject it to high temperatures, then that one will perform very good. But if you take a metal, you subject it to high temperature, then it won't work good. So this statement and this statement work antagonistically, meaning they oppose each other. Okay? All right. Hope that was clear. So do we have question or we are still on the same page? Am I clear or am I complicating things or what is the problem?
Yeah.
However,
So, I couldn't get the part where you said which statement and which statement oppose each other.
I was saying this statement here, we are talking about the conductivity of metals. And then here we are talking
Okay.
about the conductivity of metalloids, right? So I'm saying
Okay.
for metals to be good at conducting electricity, you should
Okay.
increase their temperature. If you increase their temperature, their conductivity of electricity will decrease. They won't conduct electricity better. And then metalloids, you have to subject them to high temperatures. When you take metalloid
Okay.
and then you subject it to high temperature, then it will conduct electricity very, very good.
Okay. So can, in simple words, can we say conductivity is indirectly proportional to the temperature?
You say conductivity is what?
I, in simple terms, can I say conductivity of indirectly proportional to the temperature?
I think I heard, but you're breaking at some point. But I think you're saying conductivity of metals is inversely, ne?
Yeah, indirectly proportional to the temperature.
Yeah, it is inversely proportional to the temperature. We have inverse relationship between the conductivity of metals and the temperature.
Right. Okay.
But for metalloids, it's a direct proportion. We have a direct
Okay, yes.
proportion. Yes, metalloids and the temperature. Yes. Good observation over there.
Okay.
All right. Now let's talk about the insulators. When you talk about the insulators or the insulators, I love saying insulators. When you talk about the insulators, these are not good conductors of electricity at all. Take a wire, take your charger, right? Um, I want the cable to be more specific. Let's talk about the cable, the cable of your charger. There are conductors inside of that thing, and then outside the outer part is a plastic that coats or that covers the conductors inside. So the conductors that are inside of your cable, your charger cable, they are good conductors of electricity. But the outer part that coats or that covers the inner part, it is an insulator. That's what we call an insulator. So the insulator, we say they are not good conductors of electricity. They are there to shield or to protect the internals. So at this point in time, we say that metals have electrons available to allow electrical conductivity. We know that. I said to you, those metals, those electrons, they're normally called that free moving delocalized electrons. But when you talk about the insulators, which is non-metal, insulator is a plastic, it's a non-metal. So the non-metal do not have electrons available to allow electrical conduction. And we say they are poor conductors. So non-metal is a poor conductor because it does not allow, because it doesn't have electrons. There are no electrons that will conduct electricity. So insulators are considered to be the non-metals because they do not have the electrons, and they are also considered to be poor conductors of electricity. Not only for electricity, as well as poor conductors of heat. So materials, remember we are still on the material part. The materials that do not allow conduction of electrical conduction are called insulators, which is this, right? And is a non-metal again. So these are examples of insulators. A glass. Have you ever seen someone conduct electricity using a glass? No, that's highly impossible. You're mad. Have you ever seen someone using a wood to conduct electricity? No, that's absolutely impossible. Have you ever seen someone using a clay to conduct electricity? No. And then let's talk about the sulfur. No. So these are considered to be the insulators. For example, the glass fibers, some other cables, they make use of glass to protect them most of the times. So yeah, but by the way, these are most definitely part of insulators. They are not good conductors. And then here are the examples. Uh, Also, we can make use of cooler box, which is made up of a plastic. It insulates the temperatures that are inside not to escape easily. It's an insulation and stuff. Even the blanket that you sleep with, it insulates you. It insulates your heat internally so that in the system, inside of the inside, so that the heat doesn't go outside or the heat doesn't come in. That's why most of the time when you're inside of the blanket, it is always hot, right? You are keeping the warmth. Remember, your body generates heat. When you breathe, you generate heat. When you shiver, when you do whatever, there is energy. There is a breaking down of molecules within your body. So the breaking down of those molecules within the body, it releases heat. So, or it releases energy. And that energy, when you're inside of the blankets, it will accumulate inside of the blanket. And then the blanket, it is there to protect the escape of the energy out of the blanket. So that blanket, it serves as an insulator. Okay, all right. Now let's talk about the thermal conductors and insulators. So we have the thermal conductors and insulators. This will most definitely explain what I was actually talking about. Okay, let's start with the diamond. Diamond is the best conductor, right? No, 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 no. Yes, diamond is the best conductor, but the worst insulator. Meaning diamond can conduct. For sure, maybe you've never heard this before, but a diamond, it is a best conductor. Thermal conductor, by the way, we are talking about heat at the same time, right? We're talking about heat and electricity, yes. And then silver and copper, it is a good conductor. We know that. We have seen that already. And then it is the worst insulator. Then we have the aluminum and steel. Aluminum and steel. What is a steel? You know, there's something that is called, but again, there's something that is called, there is something that is called an alloy. Alloy is a combination of different metals. When you combine guys, a steel, it's not a specific thing. A steel is a mixture of iron, copper, nickel, and then, yeah, that's a steel. It's alloy. Alloy, a word alloy, ne? Alloy. Alloy is combination of different metals. Yeah? So a steel is an alloy. It's a combination of copper, maybe iron, combined with, that's what we mean when we say steel or an alloy. So alloy and steel, they are best conductors, but they are worst in insulators. Then as we go down, a lead, it's there. It's the best conductor though. As long as we are not above the middle, as long as we are above this line, I would consider it the best because it's effective like bomber 70%, somewhere there, 65%. And then ice marble and glass, then this is where we're gonna have, yeah, the best, but the worst at the same time. So we are heading towards the best insulators now, right? Um, and then the human tissue, excluding body, this is the best insulator, excluding blood. The human tissue, remember your skin is made up of tissues, and remember your body needs temperatures internally for homeostasis. When you say homeostasis, we are talking about the balance of your internal body. So for homeostasis purposes and the processes that are taking place within your body, you still do need the temperature. So now what's happening is your tissues, could be your skin, there to shield your body not to lose much of heat. So hence why we can consider it as the best kind of insulator and the worst conductor. And then we have the rubber and the wood. These are the best insulators, right? And the worst conductors. And then we have polystyrene. Polystyrene, it's a molecule of organic compound, which is plastic. This falls under the plastic. It's a good conductor. I mean, it's a good insulator as well. And then the cork, the wool, these are also considered to be the good conductors. And then the air, it is also the good conductor. Maybe you didn't know that, but the air is a good conductor. Sorry, the good insulator. Worst conductor. Worst. Let's talk about the great insulation. What do you see here? Baby, beautiful dog. What do you see? A beautiful, beautiful penguin. Hello, penguin, penguin. And then we see a beautiful bird over there. And then these are what? These are we call them sea lions or what? So these are great insulation. For example, we know that I'll take one that will be much more easier to understand. Look at this penguin. It stays where it's very, very cold. But you have to understand that the penguin needs to get high temp, it needs to maintain the temperatures internal, even though it is subjected to a very cold environment. But the body, the way this thing of the body of the penguin is designed, it insulates the heat inside of the body so that the penguin doesn't lose much of heat into the surroundings. Since well, we know that the heat will always move from a high concentration to a low concentration. That's transfer of heat. Heat moves from where it's hot to where it's cold. You understand? That's how heat moves. Not cold moves to heat. No, heat moves to cold. That's how it works. So the body of the penguin, it is greatly insulated. So it doesn't lose much of heat to the cold environment. And let's meet on the upcoming session.